Hello there! For several months now, I've been working on a very ambitious darkroom-focused electronics project, and I think it's finally time to properly show it off. So what is this project, you might ask? I call it the Printalyzer. Its goal is to become a full-featured modern darkroom enlarger timer and exposure meter. At its core, the Printalyzer is a timer for a darkroom enlarger. That means it has a switchable outlet on the back and can turn an enlarger on and off for a set amount of time. However, it is going to be far more sophisticated than a simple clock. First, it is designed around the concept of f-stop timing. This means you adjust exposure in stops, the unit of exposure you're used to from cameras, rather than seconds. I'm not going to go in depth on this part here, but I'll put some links in the description that explain the concept better. Second, it is going to include an exposure metering probe. This probe will let you measure and gauge the contrast range of a negative before printing it. The idea is that you can figure out a fairly decent choice of both contrast grade and exposure time before you even make a single test strip. Finally, and perhaps most importantly, I'm designing this as a modern device. That means its software will be updatable, its peripherals will be flexible and interchangeable, and its capabilities can actually improve over time. Oh yeah, and the project is entirely open source. All the code, schematics, and design files are available in the project's Git repository. I'll provide a link to it in the description below. So why am I building this? Why bother to take on such a big project? Don't similar devices already exist? Several do, in fact. You can find everything from polished commercial products to crowdfunding campaigns to a lot of homebrew hobbyist projects. Okay then, why not just use one of those? Well, in short, I found myself increasingly frustrated with what's currently out there. Most of the commercial products are quite expensive and were designed and built around the mid-1990s. So while they do get the job done, they have a lot of limitations that we don't need to put up with anymore. They have a limited display, are hard to use without constantly referencing a manual, their firmware is difficult or impossible to update, and their features are somewhat constrained. Meanwhile, the more modern projects seem to forget the things those old devices actually did well. Things like a sturdy case, real clicky buttons, and a nice no-nonsense display for the most important features. They also occasionally suffer from scope creep and try to solve more general needs than just running the enlarger. Finally, it's rare that they even try to tackle the exposure metering problem. So, what are my goals for this project? I'm going to use real clicky buttons and have enough of them. I'll consider an encoder knob like all the other modern projects, but it's not a substitute for those buttons. I'll use a graphical display whose layout can be changed depending on function. Having nice big 7-segment style numbers for the exposure timer no longer prevents me from having graphics or text menus when they're a better fit for the situation. I'll have enough program and settings memory that device functions are not arbitrarily limited. I know this is mainly a jab at some of the older designs, where they had many versions that differed very little in terms of hardware. I'm going to include a USB port. This makes it easy to save and load settings, update firmware, and even connect peripherals. Have a meter probe interface with enough flexibility to enable any future features I feel like adding. I'll include a blackout switch that turns off the darkroom safe lights and all of the device's display features. This one is mostly useful to those of us who need complete darkness, such as for color printing, and would rather not have to throw a cover over the timer. What will I not be doing with this project? There are a few items I consider to be anti-goals, things I have no intention of making this project do. It's a short list, but hopefully a relevant one. It will not be a multi-purpose darkroom timer. That means no timing of film development. This timer is meant to sit next to the enlarger, not to be carried around the room and used for everything. It will not require any sort of smartphone app or computer interface to set it up. Everything it can do can be configured directly on the device itself. It's time to go ahead and build my second Printalyzer unit now that I have all the parts in place. This unit is probably going to sit in the darkroom while my first prototype will sit in my office for software development. So the first thing that you need is the enclosure. And the enclosure comes on this big board of stuff from Front Panel Express. This is a very nice way of building something like this. It's a bit too expensive for mass production, but for prototypes you can kind of justify it. So all the parts of the enclosure are on this big board here. We'll open this up and put it together. In addition, I also have the circuit board, which I assembled at the same time as the first prototype. And as far as I know, everything on it is working correctly. I actually used this as a lab reference quite a bit, just so that I could sanity check anything that wasn't working on the other unit. Also have switches and wiring assemblies that I'm going to need to put some things together. Also all the keycaps and hardware. For this one, I'm going for a light gray silver theme instead of black, because as good as black looks in room light, it's nearly invisible in the darkroom. So yeah, let's get started. So the first step is going to be to open this thing up and take all the parts out. So let's adjust the camera down a little bit. Pull this open. They do a very nice job. So you can see all nicely engraved. Let's put these parts off to the side. This is the top of the unit. We're going to have to go inside in a minute because this area here for the display, I need to go ahead and tape a filter in that spot to make the display darkroom safe. Bottom, simplest panel of the whole device. The side profiles, which are the cheapest part of the whole device. And of course, the back plate. So let's take it inside and get our display filter taped onto the underside of the top plate. We have the top plate here, the filter, which is a piece of Roscoe Fire Red Cinema Gel taped between two pieces of clear plastic. This makes the display darkroom safe, some strong black tape, and some scissors. So we just flip this over, put this in here. The clear tape in there is just to hold it together for the purposes of assembly. The black tape is what's actually holding it in place. This should do the trick. We can now put this on top of our display unit and not worry about it fogging paper in the darkroom. Here we have the main circuit board of the Printalyzer. This is actually the bottom of the board, which is the side that faces the top of the enclosure. As you look across it, we have several buttons to control all the functions, a whole bunch of LEDs surrounding the buttons to make them more visible in the dark, a couple of LEDs that are embedded in the buttons over here that may be useful for indicating state. Over here, we have an encoder knob that can be used to make fine adjustments. In the middle is an OLED display module that will have a red filter on top of it when it's installed in the enclosure to make it darkroom safe. In the back of the unit, we have the main power input and the enlarger and safe light power outputs. Other than that, there isn't all that much on this side of the board. Here we have the top side of the Printalyzer circuit board. This side is actually facing downward inside the enclosure and is where most of the components are located. In the back, we have our power input, fuses, switch connection, power outputs for enlarger and safe light, relays for controlling those outputs, relay driver over here. Here is our DC power supply for all the electronics. This steps down from mains to 12 volts. And here we have our 5 volt and 3.3 volt regulators. Surrounding this section are a whole bunch of test points so that I can safely power this on the bench off of a benchtop power supply. Over here, we have the microcontroller that is the brains of the unit. And in front, we have a USB port for connecting various peripherals, a mini DIN port for connecting our meter probe, programming connector, and ports for the foot switch and the blackout switch. And over here is our buzzer, which can be used to indicate the progress of timing. So there you have it. a fully assembled Printalyzer all ready for use in the darkroom. It's finally demo time. I've brought my Printalyzer into the darkroom where I'm going to hook it up to the enlarger alongside its metering probe and foot switch. And then I'm going to go ahead and demonstrate a lot of its basic functionality. This includes printing, test strips, and burn dodge adjustments. Then I'm going to give a quick overview of some of its more advanced features, such as enlarger calibration and paper profiling. We'll begin with a quick overview of the display and the buttons. So over here you have the currently selected exposure time, contrast grade, and paper profile. This button starts an exposure. This turns the enlarger lamp on and off for focusing. Up and down adjust the time, left and right adjust the grade. This button adds a burn dodge adjustment. This one goes into test strip mode. This goes into the menus, and this cancels. Furthermore, there's an adjustment knob up here that can be used to make fine adjustments to the exposure time. Now, because this is technically an f-stop timer, the up and down buttons actually adjust the time in stop units rather than even numbers of seconds, as you can see. And this is currently going in quarter stops, but if you press buttons at the same time, you can change it all the way down to 1 stop and all the way up to a 1/12 of a stop. Contrast grade selection primarily matters when metering, so let's go ahead and take some meter readings, and I'll show you how that all works out. The metering process begins by turning on the enlarger in focus mode. Now that you see the projected image, we take the meter probe and first we sample a highlight region. And as you see, it's placed the tone for that at the light end of the scale. Now let's take a reading in a shadow region. We now see where that tone follows relative to the first tone. Now let's take a couple more readings to populate the scale. Now on the tone graph, you see where all the readings we took fell. As you adjust the exposure time, you'll see those move up and down. And if you adjust the contrast grade, you'll see them move in and out. And if you want finer adjustment, then you can do this way. If you push this button once, you can adjust in raw 1/12 of a stop increments for fine tuning. Or if you like setting an absolute time, you can long press this button and then adjust in seconds directly. Now that we've taken our readings and placed them along the tone graph, it's time to demonstrate how test strips work. To make test strips, you press this button to go into test strip mode. And now what it shows you is what it's going to be creating for the test strip. By default, it's set up to do a 7-patch strip, and it will go incrementally. So if you press this button, you get the base exposure. And now it shows to cover the first patch. So we cover the first patch and go again. And this keeps proceeding until we get to the end of the test strip. Now, the advantage of this sort of display is it takes advantage of the graphical capabilities to show you the progress you're making on creating the test strip so you don't lose your place, which can happen quite easily when you're doing a lot of things in the darkroom. Now, let's say you finished your test strip and you've done your first print and you've decided that there's an area you want to burn in a little bit, so you want to add a burn adjustment. So what you do is you press this button, and now you can add burn and dodge adjustments. A dodge adjustment, if you hit down, will subtract from the base exposure and just act as a selective burn of that last little area you're dodging. Or a burn adjustment will add to the base exposure. And as you can see, it'll even show you the tone graph changing as you set your burn. So let's say we want to do a burn of 3/4 of a stop. We'll save that. Now over here, we see that we have a burn adjustment set. Now you can have several burn adjustments, but only a single dodge adjustment. And this, I guess you could see, is your exposure program. So now that we're ready, we're going to do our 13-second base exposure, which it will count down. Now it'll say that we have a burn exposure set for 8.92 seconds. So we get our equipment ready for burning. When we hit this button, there'll be a brief countdown and then it will start. So there you have it. Burn and dodge adjustments, test strips, and exposure metering. Now, let's say sometimes you like to print color. While the Printalyzer doesn't yet have the ability to act as a color analyzer, it does have one feature that I've added specifically because of my experiences with color printing. When using a normal timer, the problem is I have to turn my safe lights off and I have to put something over the timer to block its light. This gets rather annoying. So, to make this easier, I added a blackout switch. When you flip the blackout switch, it turns off the safe lights and off all illumination on the timer, but the timer itself is still fully functional and can be used to time exposures, burn dodge adjustments, and test strips just as if the display was on. The first advanced feature I'd like to show you is enlarger calibration. This is something that it occurred to me it would be relatively easy to do simply by virtue of having the meter probe connected. This is a feature that is useful even if you are not using the meter probe to determine your actual print exposures. What it will actually do is measure the performance of your enlarger with respect to its light output and being turned on and off to give you far more accurate exposure timing. Now, if you're doing exposures in the range of 10, 15, 20 seconds, this doesn't really matter. But if you're doing short exposures, such as is common with more sensitive color paper or with a bright enlarger, or if you're doing incremental test strips where the patches can actually be pretty short, this really does make a big difference. I've done some tests putting it head-to-head in incremental test strip mode with my RH Analyzer Pro, and this thing has much more consistent performance on incremental test strips. In fact, you could not tell a meaningful difference with a densitometer between an incremental test strip and a test strip with each patch as a separate exposure using the Printalyzer. With the RH device, you could tell a small difference. Now, enlarger calibration is right here in the menu, where you can add a profile, where the profile will have the enlarger name, turn on delay, rise time, which is how long it takes the light to get from starting to go up to full brightness, rise time equivalent, which is the equivalent light if it was at full power for that whole period, turn off delay, which is how long between flipping the switch and the light starting to fall, how long it takes to fall, and the equivalent full power exposure. Now, I don't expect anybody to know these numbers manually. Oh, and color temperature, which can be useful to figure out whether you've accidentally left a filter in the enlarger. So what I have is this calibration mode. Now, the way the calibration mode works is it will go ahead and run the enlarger through a series of on-off cycles, measuring the light intensity at a rapid rate throughout these cycles, and it will actually go ahead and calculate all of these numbers for you. Now, when you're done, you probably want to give your enlarger a name. Obviously, you can use this little on-screen keyboard thing to do it, but it is a little annoying. So, we have a USB port. And what can you plug into USB ports? USB keyboards. And if you plug a USB keyboard in, what you can actually do is go ahead and type directly on the keyboard. And that makes it a lot easier. Paper calibration is the last topic that I'd like to cover, and it can be a fairly complicated one, so I'm going to try to not go too in-depth right now. But basically, the Printalyzer can work best when it knows the full characteristic curve of your printing paper at every contrast grade. Now, the way it does this is in an exposure unit that I call the print exposure value. Some enlarger meters would use a baked-in profile from which you would figure out your own offsets. I wasn't too big of a fan of this approach because it relies on magic numbers. So instead, I'm basing all of my profiles off a value that is directly related to a calibrated light reading. The print exposure value is in the same units that a paper's contrast range is typically measured in. It is a logarithmic version of the light exposure in lux seconds multiplied by 100 to give you a convenient number. So the way calibration works is you first put the Printalyzer into calibration mode. You then take a light reading with the meter probe, and it will tell you the print exposure value that that reading corresponds to. You then go ahead and expose a step wedge on paper, process it, and measure it on a densitometer. Finally, you feed all this data into the Printalyzer, and it will go ahead and calculate the characteristic curve of the paper from these readings. All it really cares about at the end of the day for each contrast grade is three numbers: the exposure for the low end of the curve, the exposure for the high end of the curve, and an exposure point in the middle known as the speed point. From these, it can calculate a fairly accurate tone graph that can be used for print metering. Now, because I have a USB port, it's actually even possible to directly connect the densitometer to get the numbers into the Printalyzer with a minimum of fuss. I currently support directly connecting either the Heiland TRD2 or via a variety of common USB serial adapters, the X-Rite 810. I could probably support anything else that has a serial or USB interface, given some documentation on that interface or experimentation with it. Press these buttons to put the Printalyzer into calibration mode. Then turn on the enlarger lamp and take a meter reading. We're now going to expose a step wedge at a print exposure value of 220, which is a good starting point. But if we change the exposure time, as you see, the print exposure value will adjust accordingly. Now, in this mode, if you were to do a test strip, it would show you the print exposure value for each patch of the test strip, which can be used for fine-tuning. When doing paper calibration off a step wedge exposure, the first thing you want to do is make sure that you have your step wedge properly configured. This is currently configured for my Stouffer T2115 step wedge, where I input the number of steps, base density, density increment, and then, just to keep everything extra accurate, I can go in here and individually calibrate each step if it deviates from the spec. Then we go over to add a new paper profile. We can put in a name. The first thing we need to know is the maximum net density. Now, the way this works is it's basically max black on the paper. So what we'll do is we'll select that, then we'll come over to our densitometer, and what we're going to do is we're going to take a reading. Now, as you'll notice, the reading from the densitometer gets read directly into the Printalyzer with no need to write it down. So we'll save that, and then go over to the grade we're going to calibrate. And over here, it basically wants to know what exposure, speed point, and ISO range that we're going to use. Or, if we're going to be calibrating from a step wedge exposure, we go to measure from step wedge. So this is the step wedge we're using. We can preview its properties. The paper D-min, which is useful if you have a densitometer that you typically don't zero on the paper, like the X-Rite 810. With the Heiland you do, so it's not an issue. Then the paper D-max, which we've already measured. The exposure value that we used when doing this, which would go to the last number that you had used, but I'm gonna just manually set it to 220. And now we go through the steps and we measure them. So this can be a tedious process, so let's cut to the end. Now that we've finished entering our densities for all of the steps on our strip, we'll hit calculate, and it will go ahead and calculate the characteristic curve from our measurements. Now, the measurements I took there were a little quick and sloppy, which is why the curve looks the way it does. But normally this curve would look a little bit smoother. And you see the print exposure values for the base exposure and the speed point and the ISO range of the paper. So if we like that, we hit OK to accept it. And we've now calibrated that grade of our paper. There's one more little nice to have feature that I'd like to show off. If you're like me and you have an enlarger with a color head, and sometimes you like to use that color head instead of under the lens filters for your contrast grade, I added a little thing that makes that experience a little more pleasant. So if you go into your paper profiles, and I put it here simply because the contrast filters you use are specific to your paper calibration, because they do affect exposure. You can go down here and select your contrast filter type. Regular just assumes you're using normal under the lens filters, but I've also programmed in the conversion tables for a bunch of different color heads. So if we select mine, save changes, and now what you'll see right here is the color head settings for the selected contrast grade. And this is just a nice to have to avoid having to reference a sheet of paper on the wall when printing. So there you have it, a little demo of the Printalyzer and what it can do. Now I think it's time to clean up in here, go back inside, and wrap up the video. So there you have it, an overview of my Printalyzer project and its current capabilities. So whenever I bring up this project, there are a few questions that invariably get asked. The first one is always, can I get one? Well, right now the answer is you can build one yourself if you're familiar with assembling surface mount electronics. Otherwise, I would like to turn this into an actual sellable product someday, but there are a few hurdles I first need to overcome, mostly dealing with certification issues, because it is an electronics project that switches mains electricity on and off. So that's something I'm just going to have to deal with at some point. And there aren't many good workarounds to that issue. The next question that is always asked is, will I be doing anything to help control LED-based enlarger heads? Well, the problem with answering that one is there's no common standard for what it actually means to control an LED enlarger head. Everyone building a commercial product seems to have their own control box that I may not be able to time in the first place. And beyond that, there's a whole load of do-it-yourself projects that all come up with their own control schemes. So it's hard to have a standard solution to that problem. But someday I am going to have to tackle it. But for now, it's kind of on the back burner. Beyond that, you see where the project stands. I'm continuing to work on it. I expect more revisions of the hardware. There's certainly areas that I can improve. But yeah, it's coming along pretty well. So I think I've taken enough of your time for now. I'll obviously have links to all the project materials in the description. I hope that was an informative and interesting overview. And have a nice day. Bye.